All right, so the title of today's notes is 1.3, Raising Money. But in reality, what we're doing is we're using linear relationships. So let's take a look here. It says Leanne sponsors. So each student finds sponsors who are willing to pledge. So like the Walk for Jake. If you did the Walk for Jake and you got somebody to pledge money for you as you walked, you can kind of equate it to these three people. So we've been dealing with Leanne, Gilberto, and Alana. Leanne, her sponsors pay $10 no matter how far she walks. That means if she walks for a kilometer, she gets $10. If he walks for 100 kilometers, she gets $10. So no matter what, she gets $10. And so what you can see is this represented in the table I created, where Leanne, no matter how many kilometers she walks, okay, so this isn't time now, this is kilometers, she gets paid a certain amount, and she's getting paid $10 no matter what, and that's represented in each individual line. So you notice it doesn't go 10, 20, 30, 40 because no matter how far she walks, she's getting 10. She might as well not even walk in reality. Now Gilberto, on the other hand, he gets $2 per kilometer. So you could see that he begins at 0, all right? And because he begins at 0, he begins there because he didn't walk anywhere. But he gets $2 for his first kilometer, $4 for his second, 6, 8, 10, and you can see for him to beat Leanne, he's got to walk 6 kilometers for him to earn more money than she would. So he's definitely got to walk that to earn more money than Leanne would. Now Alana, on the other hand, she gets a unique sponsor. They make $5 right off the bat, $5 donation, and then they're going to contribute 50 cents for every kilometer. So you can see that she begins at $5. And then for every kilometer, you can see her going up 50 cents. So 5.50 to 6, 6.50 to 7, 7 to 7.50, and 8. So she's making slower progress. Although she begins at $5, she's only going up 50 cents per kilometer. So you have three people. You have Leanne, you have Gilberto, and you have Alana. And each one of these can be represented in an equation. All right, so Leanne, so the equation we're going to be really utilizing is this y equals mx plus b. Just a reminder, this is the rate of change or the slope, and this is where you begin, or the y-intercept. And I'll show you what that means in the next slide. Okay, so there's our formula, and each one of these people is going to utilize that formula. All right, so Leanne, her formula is y equals mx plus b. Well, she has no slope. All right, she has no rate of change. She's not going up a certain amount every time, meaning, for every mile she walks, she doesn't get anything. So that's 0. So y equals 0 because she doesn't have a rate of change times x, but she does begin at 10 and end at 10. So in that particular case, we want to put in 10 right here. So her formula in reality is y equals 10. All right, so y equals 10 is her formula. Real simple. So no matter what x is, x could be 1 to 1,000,000, her y will always be 10. Now Gilberto has a different formula. His formula is y equals, and he does have a slope. His slope or rate of change is $2 for every mile. That x is his, or kilometer. That 2 is his $2 per every, that rate of change. That's what that is. Now, his plus is 0. He doesn't begin with any money added to his account. He doesn't start anywhere. Alana, on the other hand, has the most complex formula. Her formula is y equals, and this is where it gets tricky. We need to recognize the rate of change is 50 cents. So I'm going to put in 50 cents, and then x. For every kilometer she walks, that's x. All right, 50 cents is how much she makes every kilometer. Now, she begins at $5. So it's not about where they list the 5 or the 50. You just have to be aware this is the beginning. All right, they might put that first in the word problem, or they might put it last. It doesn't matter. If they put it first, it goes where the begin or the B is. All right, so there's their three formulas. And I want to show you how this is represented in graph form. So here's the graph, and here are those formulas I was saying for Leanne. Here's Leanne's formula, y equals 0x plus 10. So this is Leanne's line right here. It's constant. it crosses at 10. There's its y-intercept right here. And then for every value of x, y is 10. So no matter how far over on this number line you go, this never changes. There is no slope, so it's 0. So it's $10 for every kilometer, no matter what. Gilberto's formula is represented here. We said 2x plus 0. So that is crossing, the y-intercept is crossing at 0. And then you could see the rise over run, $2 for every 1 kilometer walked. $2, so there's $4 for every 1 kilometer walked. And you can just see that rise, constant rate of change, $2 every one, $2 every one. And it starts at 0, it begins at 0. The last formula, right here, Alana's, you could see that her slope is more gradual. She's only going up 50 cents. So his slope's, all right, Gilberto's slope, you could see, is pretty profound. It's going up pretty high, $2 every one. And Alana's over here, you could see, is much more gradual. You could see she crosses at $5. That's where she begins. Okay, so that plus 5 goes right here. And then that 50 cents, that's why it's so gradual, that 50 cents. It's going up every kilometer, it's going up 50 cents. So you don't see a very gradual. So for every, it takes a whole dollar, 2 kilometers for a whole dollar. So she's got to walk 2 kilometers for $1. 2 kilometers walked for $1 of increase. Okay, so that's how it's represented in graph form.